We're going to look at chapter 1, we're going to look at univariate data, have an overview of this one. I really enjoy this diagram because it explains a lot to me. Obviously we've got all types of data and that can be split up with numerical data and categorical data. If we look at numerical data, typically you will get answers in numbers, but not always, because those numbers can represent a category. So example would be like 1 to 10, explain how satisfied you are, 1 being very low, 10 being high. That would be categorical data because it represents actually a word, and that would be ordinal because you could order that. So you got to be careful of that. Like a good one was the postcodes, because postcodes is categorical data because it doesn't it represents actually like a suburb, and there's no order to that either. So that would be nominal. With numerical data like weight, anything like that, measurements, that's going to be numerical. If it's continuous, that means it can take any value on the number line. So that's sort of what I think about a number line, and I think of, well, if it can take any value on there, it's going to be that. Whereas discrete data is a bit different. It can only take, specific values on the number line. So it's only going to be like, specific points on there. So a good one that I use, for example, would be, paying by credit card. You can charge to the nth degree, so that would be continuous data. Where if you pay by cash, it's to the nearest 5 cents. So that would be discrete data. It's really important to make sure you understand how we classify each of these, because from here we actually make different types of graphs. So for example, categorical data will do bar charts or pie charts. Numerical data will do more histograms. If it's continuous data, we need to always do class intervals, where if it's discrete, we could do possibly a histogram that shows discrete, or we might have to, if the range is quite big, still make it into class intervals. So how do we display categorical data when we're looking at that? We can make a frequency table. Notice this is a frequency table or a percentage frequency table. The percentage would be here. That doesn't always need to add up to 100 because sometimes you might have rounding errors when you're calculating it, but that is fine. So don't worry if it doesn't, just add it up to what it is. Also, we'll do a bar chart, something like this. Note with a bar chart, one thing we should always be looking at is the frequency. Now, is that frequency or is it a percentage frequency? Because if it's a percentage frequency, when you actually ask questions and to interpret it, and we might need to change it to a count, you'll need to change the percentage back to a count. So again, you might have a frequency, but asks, what percentage of people chose to choose car. And now if you look at this, you'd be like, oh, you might answer 7%. But if you actually look at car, 7% as a percentage out of the 14, because there's 14 people surveyed, would be 50. So you'd have to go 7 plus 5 plus 2, which is 14. 7 divided by 14 is 2. So just be wary of that. Always have a look and make sure you note that. If you do make that mistake, that should be in your reference book to take note. Is frequency in percentage or count? Also, is the question asking you to give a percentage as an answer or a count as an answer? That's really important too. So just take note of those, because they always throw in a spanner where it will try and trick you. They'll give you, a question that you'll need to convert possibly. Not always, but just keep mindful of that one. That's pretty much the only way you can slip up in here. You can also have a segmented bar chart as well. Again, this can be percentage frequency or frequency count. So just take note of that one as well. Again, each of these shaded areas represent how many is there. So notice the car has, what do we got there? 4, 5, 6, 7. This is going up by 1, so we've got 7 in here. Now, what some people do wrong is they might go, train. Oh, train has 12 because they just read off the top. But it doesn't. It starts at 7. So the train actually starts here at 7. So it goes from 7 to 12. So 12 take away 7 is actually going to be 5. And that's how we need to calculate that one there. So you're looking at how much of it actually takes up. Same thing you do if it was percentage. You just try and calculate that too. So be careful of that, because typically they won't give you the bottom one. They'll give you, one on top or in the middle. Again, when we look at numerical data, we don't leave gaps in it like we did with a bar chart. Notice there's always going to be gaps in the bar chart. Numerical data, we can do again a frequency table. Again, be careful if it's asking for a percentage frequency or if it's asking for a count. And again, our class intervals should always be exactly the same size. So a classic one is, going from 0 to 10 and then, 10 to 19. The numbers shouldn't repeat on here. So just be careful of that. They should be clear to know where everything is. So this is 50, including 50% up to, but not including 60. This is including 60% up to and not including 70. So if we did this histogram, clearly, just a quick guess, if this was like, so if this was 60, what's going on here? If this was 60 here, and then we've got another line, and that is 70 here, hopefully you get what I'm saying. If you had a histogram in here, like this, and this is the dodgiest histogram going around, don't do this in your exam. This would represent this column here, okay? It includes 60, but not including 70. Don't forget, if you've got exact values, the marker will be in the middle, okay? So that might be, for example, 4. If that was number 4 underneath, that means every value in there is exactly 4. Now, if the marker's on the side, like it is here, it's representing a class interval. So this, at the start, includes that number up into 70. And obviously then the next one, if we had one going to 80, here, this one here, let me just get this. This one would represent, this column here would represent 70, including 70, up until 80, but not including 80. I wish I could draw better on this. I do apologize. Clearly, I've been out of action for a little bit with using the tablet, so welcome back. Obviously, we can explain as well with shape and things like that. So we're going to look at which way it's skewing. This is negatively skewed. We can also see the range. So this would be from 3 to 10. So the range of this would be like the minimum value would be 3. The maximum we can say is positive 10. So you'd expect that to be 7. I could also do the interquartile range in here because I do have the frequency on the side. So I'd need to add those all up and figure out where the interquartile range is, or the median as well. I could figure the median would obviously then be a range as well. A class interval. We can see if there's outliers, possible outliers, like this may be a possible outlier as well. Notice it's possible because you'd need actually to calculate it to be an outlier. So if it has a possible outlier, you might say. And then we can just talk about the shape. We can talk about being positively skewed because it skews like a skewer towards, negatively skewed because it skews towards the negative direction because this is going negatively. This is going to be negative numbers. And that would be positively skewed because it's skewing towards the positive. You can also talk about the modal interval. The modal interval just means what's the most common. You should know this. So clearly the modal interval between 2 to less than 3. So important that we can write it like that. Or you could also write it like this. As well, with 3 there. And then we also have symmetric, and we've also got bimodal here too. Now, you'll with histograms you can explain other shapes, like you could explain U-shape or uniform distribution. However, I really don't see those. I more see positively, negatively skewed, or approximately symmetrical. So, which is what you'll really get in your exam and your stacks. When we're looking with log scales down the bottom, so this isn't a log scale, but if we want to convert it to a log, we're literally going to get on a CAS. And in your CAS, we're just going to go to the keyboard. We're going to go to mass 1. We're going to go log 10 if it's the exact values that we have, like the original data, and 15. So the log value of 15 would be 1.7, which sounds right because it's about a power of 10. Now, if I had a log value of 2, for example, how do we know what that is? Well, that's just 10. We're going to put in 10 and hit this little to the power of button here, to the power of 2, okay? And that's 100. Notice if I do 10 to the power of this previous answer that I had, I should get 15 as a result, okay? And we get 15. So we really need to be careful if our histograms have log values or not. We've also got to be careful again with the frequency, if it's positive, if it's percentage, or if it is, or if it's count. So we've got to be sure of that. With these, like the way I view this is I see, -1 as a tenth. I see 0 as, because 10 to the power of 0 is 1. I see 1, which is 10 to the power of 1, is 10. 10 to the power of 2 is actually 100. So I see that as those numbers. So be careful if you're looking for exact values again. Like if it's asking for, what is the height of, what's the height of the biggest plant in here? Some people may say 2, but you could say it's about 100 meters, because that's 10 to the power of 2, which is 100. In your calculator, hopefully you know how to log intervals. So if you've got everything here, you just literally can go log of this list, previous one, and that will give you all the values there, and therefore you can actually then do a histogram of that. So when you need to find the median, we're looking at finding the median from a dot plot or IQR. Sometimes it might say how much is in the data set. So it might say, instead of counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it might say there's 10 numbers in here, which is really like a bit of a quick way. If it's 10 in here, then we actually know that we can go 1, 2, 3, 4, 5, 10. We know 10 plus 1 divided by 2 is going to tell us that the location of the median is at 5.5. So it's at, in between the 5th and the 6th number is where that occurs. really doesn't want me drawing today. 1, 2, 3, 4, 5. So it's in between these two, which actually be 4.5. That would be the value of the median. If we need to find the IQR,